Write the equation of the bolded line in the diagram shown below. So we want to take this three-dimensional diagram and think about it two-dimensionally. So you can think about this sort of three-dimensional object, kind of like a potted plant base, and think about putting the origin right kind of in the middle and looking at it from a perfect side view. So if I looked at this from the side, I would see a two-dimensional object. It's going to look like a trapezoid, a symmetrical trapezoid. Try my best there. And so again, the origin, 0, 0 is here. So this is the y-axis, and here's the x-axis. If this whole base is a length of 4 meters, then this point here would be the coordinate point 2, 0. And then this height here is 5 meters. So that's going to be the y value up here. If this whole distance is 6 meters across, then half of that is going to be 3. So this coordinate point up here in the corner is going to be 3, 5. Because again, this height is 5, half of 6 is 3. So if I want to find the equation of the bolded line here, I want to find the equation of this line right here. I want to find a point and a slope for that line to be able to write the equation of it. So I essentially want to fill in to point slope form. Y minus y1 equals m times the quantity x minus x1. Well, I have 2 points. So I have 2, 0, and I have 3, 5. So either one of those could go in for x1, y1. I'll choose 2, 0 because it's nice to have 0 as one of the values. So y minus 0 equals, we need to find our m value, and then x minus x1 is 2. So I need m, I need my slope. Well, there's two ways of figuring out what the slope is. So we have the graph here. So to find slope, I can think about rise over run. So I can think about going from point to point. I would have to go up, the rise is 5, and then I'd have to go over 1 unit. So the slope of this line is positive 5. So I'm going up 5 over 1 to get from 2 to 3 is that distance of 1 unit. So my slope here is 5. We could also, because we have 2 points, we could have used the formula to find slope, y2 minus y1 over x2 minus x1. So we could have said m is 5 minus 0 over 3 minus 2. And that gets us our 5 over 1. But in any case, there we have it. So we have y is equal to 5, if I distribute, 5x minus 10. So that is my line solved for y. And so that would satisfy what this problem is telling me to do, write an equation. This is an equation of a line in slope-intercept form, solve for y. Often in the actual calculus class, we're going to want to solve this equation to be a function of y, so solve for x. So an equivalent answer here would be y plus 10 is equal to 5x, or y plus 10 divided by 5 is equal to x. So really for this problem, both of these are correct. So there are multiple ways to write the equation of a line, but we're typically going to want to solve the equation so that x is a function of y. Write the equation of the bolded curve in the diagram shown below. So here, three-dimensionally, we have a sphere. But I want to think about this, just like in the last one, as a two-dimensional object. If I look at a sphere from the side, what I really have is a circle, right? So here, what I want to do, what I'm being asked for, is the equation of the right side of a circle. And so let's put that circle on an xy axis centered at the origin. Well, what do we know about this circle? Well, its diameter is 14 feet, so that means its radius is 7. So this coordinate over here, for example, is 7, 0. This one up here is 0, 7, negative 7, 0, 0, negative 7. Okay, so how do we find the equation of a circle centered at the origin? Well, it's really nice. The equation is x squared plus y squared is equal to the radius squared 7 squared, which is 49. So x squared plus y squared is equal to 49 is the equation of the entire circle. Well, I just want the right side of the circle. So what I want to do here is I want to solve for x. So when I solve for x, I'm going to get x squared is equal to 49 minus y squared. And then I'll get x equals plus or minus the square root of 49 minus y squared. So I actually get two different equations out. Now, there's two different equations because what this is doing is finding an equation for the right side of the circle and the left side of the circle. So the equation of the right side of the circle, which is what I'm trying to find, is the positive one. So x equals positive the square root of 49 minus y squared is the equation of the right side of the circle. Now, just a quick warning, we cannot take the square root of 49 and the square root of y squared because these are subtracted. The square root does not distribute over addition or subtraction.